we want to talk now about calculating the elasticity. So let's review from your principles class what elasticity is, what it measures, and how you calculate it. And actually the way that we calculate it in a principles class is a little different than the way we're going to calculate it now. They're both perfectly useful ways of doing it, but the way that we're going to do it is going to be a little bit more simple than what you would have learned in a principles class. So I think that's hopefully good news. So remember that an elasticity is a measure of the strength of the relationship between two things that are related to each other. So we could think about, let's think about how consumers respond if the price of gas changes versus how consumers respond if the price of, let's say, Coke changes. So if we think about the price of gas, if the price of gas were to go up a lot, probably you're going to buy a little bit less gas, but you still have to drive to work or to school. You've still got about the same amount of driving that you need to do, so you're probably not going to respond very much. So the price of gas can go up by quite a bit. You'll still buy just about the same amount of gas. On the other hand, if we think about what happens if just the price of Coke were to go up, well, consumers typically are going to respond a lot to a change in the price of Coke if the price of other substitute goods doesn't change. So if the price of Coke goes up, then people will switch away from Coke. They'll buy other things. And you already know that the difference between the two is that there are good substitutes available for Coke. For gasoline, there are not good substitutes. We'll talk a little bit more about that here in a second. So elasticity helps us understand why we change a lot in the case of Coke and why we don't change a lot in the case of gasoline. It helps us put a number on how much we're changing. Okay? So the term that we typically use is price elasticity of demand. Price elasticity of demand. And the way that you calculate it is that the price elasticity of demand is just the percent change, let's write it out, percent change in quantity divided by the percent change in price. Let's write it a little bit more concisely. Let's say percent change in quantity divided by the percent change in price. And a lot of times in a principles class, I will abbreviate price elasticity of demand that way. And hopefully you remember that the price elasticity of demand is really just a measure of how steep the demand curve is. Now I realize that we're dealing in this picture with an inverse demand curve. That's fine. So let's suppose we think about a demand curve that is very elastic. A demand curve that's very elastic is relatively flat like that. If demand curve D1 is relatively elastic. A demand curve that's relatively inelastic would be very steep, like D2. Okay? D2 is a more inelastic demand curve than D1. And you might remember that another way of measuring the steepness of the demand curve is the slope. And the reason that we don't use the slope when we're talking about calculating elasticity or when we're talking about the steepness of the demand curve is that the slope has units of measure. The slope would be defined in terms of the rise over the run, and the rise is dollars and the run is units of the good. It's dollars per unit of the good. Well, that means that we can't compare two different goods. So, because if we were talking about dollars per tire, we can't compare that to dollars per apple or dollars per sandwich. And so the slope would be of very limited usefulness to us. The nice thing about the elasticity is that it's in terms of percent changes. And we can compare the percent change in terms of percent change in dollars to percent change in the number of tires that you buy. We can compare that to the percent changes and the percent change in the number of apples you buy. There's no problem comparing percent changes. So the textbook that we use is going to use a little bit different notation. For demand elasticity, it has E with a D superscript, and for supply elasticity, it has E with an S superscript. But in terms of how they're defined, it's still just the percent change in quantity divided by the percent change in price, where this is quantity demanded. Elasticity of supply would be the percent change in quantity supplied divided by the percent change in price. So our elasticities don't change. In terms of how we interpret them, everything's going to be the same. If you calculate the elasticity of demand and it's greater than 1, then we would say that demand is elastic. And if you were to calculate the elasticity of demand and it's less than 1, we would say that demand is inelastic. And then finally, if you were to calculate the elasticity of demand and it was exactly equal to 1, we would say that demand is unit elastic. So that's how we interpret the number that we get when we calculate the elasticity. Supply is interpreted the same way. Let me just say that if you would like a little bit more of a refresher on elasticity, you can always go to my principles videos, my principles of micro videos on YouTube, and you'll be able to find the video for elasticity. Just watch through that, and that'll give you more, kind of a more in-depth discussion of what's going on here. Let's just briefly review the things that determine whether or not demand is elastic or inelastic. The first one I talked about just a second ago is the availability of close substitutes. The more close substitutes are available, the more elastic demand will be. We can talk about the time horizon. Demand and supply both tend to be more elastic over longer time horizons. And the reason is that a longer time horizon gives you more ability to make adjustments, and so you respond more. And then, especially for the elasticity of demand, demand tends to be more elastic when the good consumes a larger share of the budget. So if we think about goods that consume a big share of your budget versus goods that consume a very small share of your budget, you tend to pay more attention to the prices when the good consumes a large share of your budget. So again, if you want more discussion on that, go back to my YouTube video for the principles level elasticity. Let's just review how you calculate the price elasticity of demand in a principles class. So let's suppose that we calculate elasticity. The way it's calculated at a principles level is you're typically given 2 prices and 2 quantities, and then you calculate the percent change in quantity and divide it by the percent change in price. So here's a typical example. When price equals $3, let's suppose Dave buys 5 pizzas per month. When price equals 5, let's suppose Dave buys 1 pizza per month. So here you've got a price and the associated quantity demanded, another price and the quantity demanded. What we do is we calculate the percent change in quantity, divide it by the percent change in price. Remember that when you calculate elasticity, we want to use the midpoint method. And the midpoint method means that when you calculate the percent change, you look at how much it changed and you divide by the midpoint of the two. And if you don't remember that, and you want a refresher, again, go back to my YouTube video for that principles level class and review that. But let's calculate the price elasticity of demand. So I'm going to calculate the percent change in quantity first. Percent change in quantity. The numerator is going to be how much quantity changes by, and it changes by 4. Now it's -4, but remember we don't pay attention to the signs when we're talking about price elasticity of demand or price elasticity of supply. Now, in terms of working out homework problems, I would recommend using the correct sign. Price elasticity of demand is always negative. Price elasticity of supply, always positive. So our quantity changes by 4 units, and our average quantity is going to be the average of these two, which is 3. So my percent change in quantity is going to be 4 over 3. My percent change in price changed by 2 units, and the average is 4. So this is equal to 1/2. My percent change in P is 1/2. And then my price elasticity of demand is just the percent change in quantity, which is 4/3, divided by the percent change in price, which is 1/2. Remember, if you've got a fraction of 2 fractions, the way you reduce that is you write the top one and you multiply by the reciprocal of the bottom one. So this is equal to 8/3. Price elasticity of demand here is 8/3. 8/3 is bigger than 1, so demand is elastic. So that's a nice, simple example of how to calculate elasticity. If when you took your principles class, and this is probably what happened, unless you had your principles class from me, when they taught you the elasticity formula, they probably gave you a complicated formula that looked something like this. Elasticity of demand is equal to, let's say, Q1 minus Q2 divided by Q1 plus Q2 over 2 multiplied by 100 divided by P1 minus P2 divided by P1 plus P2 over 2 multiplied by 100. For a lot of people, that's how they learned how to calculate elasticity. And I would just simply say that I'm doing the exact same thing here as what you're doing there. This is just a much simpler way to think about it. Notice that these hundreds cancel out. You might as well just forget them. And this Q1 minus Q2, that's just the change in quantity, which I've got right there. And this Q1 plus Q2 divided by 2, that's just the average quantity, which is what I've got right there. Here's the change in price. Here's the average price. So writing it out like that, for a lot of students, gives it extra complexity. It makes it feel more complicated than what it really is. So if you like using that formula, that's great. This is simpler. It's way easier. You don't need a calculator to do it this way. And again, if you want to understand more about why this is easier, go back to that principles video. Now what we're going to do is we're going to do something that's actually even easier than the 2 of these. So I guess that's the good news. Here's what we're doing. We're actually calculating, what we're going to calculate is what we call a point elasticity. What's being calculated right here with this or with this, we're calculating what's referred to as an arc elasticity. Arc elasticity. What we're going to calculate is a point elasticity. So let me show you how to calculate a point elasticity. It's actually very easy. What I'm going to do is I'm going to rewrite this formula. The elasticity, demand, this is the change in quantity. I'm going to write it right there, change in quantity. It's divided by the average quantity, so I'm just going to put average there. And then this term right here is the change in price divided by the average price. Now I've got a fraction of 2 fractions here, so I can take this bottom one, flip it over, and I can multiply by the top one. So this is the change in quantity over Q. I'm going to drop the average subscript there. Multiplied by price times the change in price. Okay. And then since I'm multiplying these two things, the order of how I multiply them doesn't matter. So I'm going to flip the bottoms. Here's change in quantity over change in price times P over Q. That's another way to write the elasticity formula. Now here's why this is useful. What we can do here, this term right there, the change in quantity, when you change price, this is just the slope of the demand curve. Slope of demand curve. It's just a number, and you can get it right from the function of the demand curve. And then this term is just a price and its associated quantity. So now what we can do, since we're working with the function of the demand curve, we can actually take advantage of that and we can calculate elasticity easier. We don't need two prices and two quantities. All we need is one price, the quantity that goes with it, and then the slope of the demand curve. This whole term is the slope of the demand curve. I don't want you to think about it as two different terms. I can rewrite this way. Elasticity is equal to, instead of using these Greek d's, I can write it this way, dq dp times p over q. And if you've had any calculus, you'll recognize that that dq over dp, that's the slope. That's how we would write. That would be the notation for the slope of the demand curve. So let me give you an example. Our demand curve is this. Let's work with the second one that we had. Quantity is equal to 600 minus 100p. There's the demand curve that we've been working with in the previous video. Now, this term, dq dp, that slope of the demand curve, all you have to do is look at this function. You can pull the slope off. dq dp is equal to negative 100. Or, if you know the calculus of it, just take the derivative of this thing with respect to p. It's negative 100. So now we've got this term. Now we can calculate the elasticity at any price. Let's calculate it at a price of, say, $4. Calculate the elasticity of demand when price equals $4. Well, we need to know what the quantity is when price equals $4. So all we need to do is plug in 4 for our p. So we get 600 minus 400. We know that when price is equal to 4, quantity is equal to 200. And now we've got the three things that we need. We've got the slope of the demand curve, we've got the price, and we've got the quantity. So we can plug them right in there. Elasticity is equal to the slope of the demand curve. It's negative 100. Multiplied by price, which is 4. Divided by quantity, which is 200. That gives us an elasticity of negative 2. So instead of having two prices and then two quantities and calculating the percent change, which is not hard, we've got something that's actually a little bit easier. All you have to do is take the slope of the demand curve and then whatever price I give you, plug that price into the demand curve to see what quantity is, and then plug it right in there. The one thing that you need to make sure of is that I could give you the inverse demand curve. The inverse demand curve that goes with this is P equals 6 minus Q over 100. There's the inverse demand curve. You don't want to pull the slope of the inverse demand curve out. You want to pull the slope of the demand curve. Okay? Notice that the slope of the inverse demand curve is negative 1 over 100, which is the inverse of the slope of the demand curve. The demand curve and the inverse demand curve have slopes that are inverses of each other, which shouldn't be surprising to you because the functions are inverses of each other. So what we need to do here is clear this off, and then we'll just kind of review a few things that you need to remember from principles, and then we'll wrap this section up. So you probably remember from your principles class that the elasticity changes along a linear demand curve. So I'm going to draw probably the picture that was drawn for you when you took your principles class, which would have been this inverse demand curve picture. Let's have a linear demand curve, and I'm going to make it go from one axis to the other. So there's our demand curve. If you were to draw a linear demand curve or come up with a functional form for a linear demand curve and then calculate the elasticity at different points along this demand curve. Remember the slope of the demand curve, you'd need to find the slope of this inverse demand curve and flip that over to get the slope of the demand curve. But you could easily calculate the elasticity at different points just using the formula that we had. The slope part's not going to change, it's just going to be different price quantity combinations. What you'll see is at the midpoint, the elasticity is going to be equal to -1. You'll see that down here at this endpoint, the elasticity is equal to 0. Demand is perfectly inelastic. And down here at this endpoint, the elasticity is going to be equal to -infinity. That one's going to be a little harder to calculate. You'll have to take a limit if you were to do it. You can take my word for it. In this range, we would say that demand anywhere between the midpoint and this point, demand is inelastic. It's the inelastic portion of the demand curve. Anywhere in here, demand is elastic. So you can see that the elasticity is not constant. The slope of this thing is constant. The slope never changes. But the elasticity changes because we're evaluating it at a different price quantity combination. So let's use here's the slope of the demand curve times P over Q. So this term is not changing. That part's constant, but we're always thinking about a different price quantity combination. You can see that up here, price is going to be high, quantity is going to be low. So our numerator will be big and our quantity will be small. And so we're going to tend to have numbers that are bigger than 1. Demand is elastic. Down in this range, we're going to have small prices and big quantities, which is going to tend to turn this thing less than 1, and demand will be inelastic. So the elasticity changes along a linear demand curve. Hopefully you remember the special cases of elasticity for both demand and supply curves. We would say that a demand curve that is horizontal is perfectly elastic. A demand curve that is vertical, perfectly inelastic. When I was taking my principles class, when I was first learning about elasticity, it at first was a little bit hard for me to remember which was perfectly elastic, which was perfectly inelastic. The way I eventually realized that was easiest for me to remember is that this perfectly elastic one is like 3/4 of a big capital E. So I just remembered, perfectly elastic. And this one, the perfectly inelastic one, was straight up and down like an I, and I just was able to remember perfectly inelastic. And then the next semester I got into an intermediate micro class, and all of a sudden I learned that these were actually inverse demand curves. And if I was thinking about the actual demand curve, I need to invert these. Well, if you invert these, then this one looks like that, and this one all of a sudden looks like that. I just realized that, gosh, now my rule is completely flipped around, and I was a little bit concerned that it would be hard for me to remember that. Well, just remember, when we're working graphically through this, we're still going to be working with these pictures. Okay, so we don't switch the graphs on you. We're still going to be putting P on the vertical axis. All of the stuff that we do when we're working with consumer and producer surplus, elasticity, changes in demand, we still put P up here. So that rule for me still worked. I still use that rule. Let's finish up this section by talking about the relationship between elasticity and total revenue. So that's one of the key things here. We know elasticity and total revenue. So we know that total revenue, which is also equal to total expenditure, I'm going to write it that way. Total expenditure, that's the amount that households spend. which is equal to the amount that firms bring in, their revenue. It's equal to total revenue. It's just price times quantity. And so what we want to pay attention to is this nice simple rule. This is a product. Price and total revenue is the product of two things, one multiplied by the other. And the percent change in a product, the percent change in price times quantity, is roughly equal, I'm going to write it this way, it's roughly equal to the percent change in price plus the percent change in quantity. That's a handy rule. That's handy out there in the real world when you're not doing economics. If you're trying to figure out the percent change in something, and that thing that you're trying to figure out the percent change in is two things multiplied together, then the percent change of the product is going to be roughly equal to the percent change in each of those things by itself. It's not exactly equal, but it's close enough. So here's what we can do. We can see how much total revenue changes in percentage terms by knowing something about how much price is going to change relative to how much quantity is going to change. And remember, an elasticity tells us that. So if we were to think about a demand curve, let's put a point, let's have our price, quantity. I'm going to put some points down here like A. I'm going to put a point here, B, and another point, C. And then down here, I'm going to put total revenue or expenditure. And I'm going to put P on my horizontal axis. Then here's what we can do. We can figure out if price is all the way down here at 0. So if price is back here, total revenue is going to be 0. If you're selling your goods for a price of 0, you're going to get no revenue. As you increase price, remember that demand is inelastic. And when demand is inelastic and you increase price, total revenue goes up. So our total revenue curve is going to look something like this. And at some point, as we increase price enough, we're going to hit the midpoint when demand is unit elastic. And our total revenue is going to stop going up. And then as we increase price more, we now reach the elastic portion of the demand curve. And when demand is elastic, price and total revenue go in opposite directions. So an increase in price causes total revenue to go down. So this point corresponds to point A, this point corresponds to point B, this point corresponds to point C, where you've raised price enough that you're not selling any units. And if you're not selling any units, total revenue is 0. So remember the general rule that you learned in your principles class. When demand is inelastic, price and total revenue go in the same direction. But when demand is elastic, price and total revenue move in opposite directions. And so this relationship between price and total revenue is very useful if you're running a firm. The last thing we want to do is just briefly review the formulas for price elasticity of demand and cross price elasticity. Let's do our price elasticity or income elasticity of demand and cross price elasticity of demand. Income elasticity, formula is nice and simple. Income elasticity, your textbook uses this notation. It's the percent change in quantity divided by the percent change in income. But we're going to calculate point elasticities, and so it's going to be dQ di times income over Q. Your cross price elasticity, your book calls it the elasticity of demand with respect to X and Y. So this is going to be a change in the price of good Y and how that impacts demand for good X. It's going to be the percent change in quantity of good X in response to a % change in the price of good Y, which is equal to, let's write it this way, dQx dPy times Py over Qx. Now, the formulas look very similar to our just plain demand elasticity. Typically what I'm going to ask you to do on a test is going to be the demand or the supply elasticity. I typically don't have students work too much in terms of the arc elasticity for income and cross price elasticity. But rest assured, they're easy to calculate. It's not hard. It's just that the demand curves have to be a little more complicated. And at this point in the class, we're not going to worry about that. So again, if any of this elasticity stuff didn't make sense, go back and review that principles level elasticity video that I've got on YouTube. And if you have any questions, send me a note, and I'll see you in the next video.